Section 17a is about logical reasoning. Logical reason is about creating statements that are logical, and a couple of definitions we're going to start with is a conditional statement and an if-then statement. They actually mean the same thing. What they are is they're a statement that can be written in the form if A, then B. Now, an important point here is that they can be written in that form. They don't always have to start in that form. Here's an example of a conditional statement, and then also the same statement written as an if-then form. The statement is, I will play outside because it is hot. It's a statement that has a condition built in. An action is taken place when something meets a certain condition. In this case, because it's hot, then we're going to play outside. Now, any conditional statement can be written as an if-then statement, and here's the same thing written as an if-then statement. If it is hot, then I will go outside, and I forgot to put the word then in there. And then's important. In fact, the if and the then are very important because they help break the statement up into two sections. They break it up into something called the hypothesis and the conclusion. This here is my hypothesis. It's the portion that comes after the if, and this is called the conclusion. And it's the portion that comes after the then. The hypothesis sets everything up. The hypothesis says, here's the way things are, here's the condition, and then based on that condition, the part that comes after the then is the result. Then I will play outside. All conditional statements can be written as if-then statements, and then once you write them as if-then statements, you can see what the hypothesis is and the conclusion. Here are some examples in which we're asked to identify the hypothesis and the conclusion. Now, if the statement is written in an if-then format, it becomes very easy. In this case, it says, if it is Friday, then Madison and Miguel are going to the movies. Well, the hypothesis is the part that comes after the if, and that's why I say if it's written in if-then form, it's real easy. So this is the hypothesis. And the conclusion is the part that comes after the then. So Madison and Miguel are going to go to the movies. That's the conclusion. Let's look at the second one. If 4x plus 3 is greater than 27, then x is greater than 6. Here's my hypothesis, and here's the conclusion. Here are some examples for hypothesis and conclusion, except this time we not only have to identify the hypothesis and conclusion, we have to write the statement as an if-then. I actually find it easier to write the if-then form first, because once you write it in if-then, as we learned in the last video, it's very easy to pick out the hypothesis and the conclusion. So let's take a look. I will go to the ball game with you on Saturday. Well, what's the condition for going to the ball game? The answer is if it's Saturday. So here I've rewritten the statement using if-then. If it's Saturday, then I will go to the ball game with you. So it's much easier to say that this is the hypothesis, if it is Saturday, and then the conclusion is I will go to the ball game with you. You see, being Saturday is the reason they're going to go to the ball game, not that the fact that they're going to the ball game, that's not the reason it's Saturday. So that's why Saturday is the hypothesis. Our next example says for a number x such as 6x minus 8 equals 16, x equals 4. So I'm going to rewrite the sentence, and if 6x minus 8 equals 16, then x equals 4. It doesn't work the other way around. It's not because x equals 4 that 6x minus 8 is 16. So first you have to have the equation, then you get the solution. So in this case, this is the hypothesis, and this is the conclusion. Here are a couple more examples of hypothesis and conclusion statements. The first one, if it is January, then it might snow. Well, because it's written in if-then form, we can easily say it is January is the hypothesis, and the conclusion after the then is it will snow. Second one, if you play tennis, then you run fast. Now whether it's true or false is irrelevant, but the statement has a hypothesis of if you play tennis, and a conclusion, then you must be fast. Now the next two are not written in if-then form, and so we're going to have to rewrite them. It says Lance watches television when he does not have homework. So what has to happen first? Does he watch television first and then not have homework, or does he not have homework and then watch television? Well, obviously, if he does not have homework, has to happen first, then he can watch television. So the hypothesis becomes him not having homework, and then the conclusion is that he watches television once his homework is done. The next one says a rectangle is a quadrilateral with 4 right angles. Well, first you have to have 4 right angles before you can make a rectangle. Because there are other quadrilaterals and just rectangles, it wouldn't work the other way around. So in this case, the hypothesis is the quadrilateral has 4 right angles, and if it does, then we get our conclusion